Okay, so today we're starting with graphing trig. Okay, just specifically sine and cosine. Okay, so the last couple of days we've been talking about the transformations. Okay, so we're kind of putting it all together. So today we're looking at this sine wave. Okay, so again, the first thing we should always do whenever we graph functions is start with their parent function. So I'm going to start by graphing the parent function of sine. Okay, with 5 key points, this is the one period from 0 to 2 pi, one full sine wave. Okay, and that's what it looks like. Now above this, I'm going to write this. This is my sine function with all of the transformations in it. Okay, so this 1 that's sitting out in front, this is my k, which also represents my center line. So my center line is at y equals 1, telling me that there's been a vertical shift up 1. This 2 right here, that is my new amplitude. My new amplitude is 2, which represents a vertical stretch by a factor of 2, which means my maximum minimum values are going to be stretched to 2 away from my center line. Okay, I don't have a b, so there's no change in period. So my period is still 2 pi, so my wave is 2 pi long. This is my shift. So I have a shift, and since this is positive, we're going to the left 3 pi over 2. Okay, so these are all my transformations. This is everything I know about this. Okay, so one thing that I do, since I know it's been shifted over 3 pi over 2, okay, I know that basically my wave is going to start here, and it's going to be exactly, since my period's still 2 pi long. So this is the basically where my wave is going to end up. So whenever I graph trig, I always start with my change in period. Since I don't have a change in period, I don't have to do any kind of horizontal stretch or compression. I do have a change in amplitude, so that's what I'm going to do first. My zero's still at the same spot, but since my amplitude has changed, my maximum and my minimums are now at 2 and -2. Okay? Now, my center line is at 1, and so what I'm going to do is I'm going to put this yellow dotted line right here. This is where my new center line is. My old center line, which was right here at 0, has been shifted up. So that's what I'm going to do next. I'm going to take my function and I'm going to shift it up 1. So this moves up here. This one goes up here. This one moves here. This one moves there. And this one moves there. So this is now my sine function. Okay? So I've taken care of my amplitude. I've done my shift up. Now I need to do my shift to the left. So everything's going to move 3 pi over 2 to the left. So this is going to end up here. And then this one's going to end up right here. Oh, no, there. Here. And then this one's going to end up right there. So here is my final transformation. I always do my final transformations in red. Okay? Now, we can double check it with what we know. So again, here's my center line right here at 1. My amplitude tells me that my maximum should be 2 away from my center line, and my minimum should be 2 away. Is that where my maximum and my minimum are? Absolutely. And does it start right here and end right here like we said it would? Absolutely. Okay, so basically knowing where my center line and my amplitude is and what my period is, I can kind of get an idea of that it is supposed to be in this general area where this green box is. That's where it's supposed to end up. Okay, so use those things that we know about transformations to kind of make sure. Now, if you really know your unit circle, you could, of course, actually plug in a point. I always tell my students, check yourself. Make sure, pick a point and basically figure out if you're correct. So what I'm going to do is I'm going to plug in 0. So 1 plus 2 sine of 0 plus 3 pi over 2. Which means basically this is 1 plus 2 and sine of 3 pi over 2. Well, if you know your unit circle, the sine at 3 pi over 2 is negative 1. So negative 1 times 2 is negative 2. 1 minus 2 is negative 1. So this is negative 1. So the coordinate 0, negative 1 should be on my graph. Is this 0, negative 1? Sure is. And 9 times out of 10, if you plug in a point and it double checks with where your graph ended up, then you are correct. But again, you have to really know your unit circle in order to do that.